Hello everyone, and my name is Han, and welcome to my channel. Today we're going to start a new series about the cryptography from a beginner point of view. So we're going to talk about the mathematics involved without entering too much details and without having to do precise calculations. But the idea is that with this background, we should be able to understand and at least interpret some of the articles that are running around in the world of cryptocurrencies. So this will begin with very basic topics such as sets, operators, integer mathematics, things like that. And hopefully it will end up at the fairly cutting edge point of cryptography right now. And we have and finally it should end up fairly close to the cutting edge of cryptography, and by that I mean ZK, zero knowledge proofs. Alright, and so without further ado, let's get starting. So today we're going to do very simple things. We're going to talk about sets. So, okay, what's a set? Basically, you have a few elements. So you have any kind of elements you want. So it could be numbers, it could be fruits, it could be colors, anything. It's basically that you want to group together. So if you have, for example, these elements, you can make sets like this or like that. And the only thing that really matters here is the question whether an element it belongs to a set. So once you have formed a set, you can ask yourself, is this element part of that set or not? And that's a yes or no question. So you can either be member of the set or you are not a member of the set. You cannot be both. You cannot be on the edge and say that you're both in and out. And that's essentially it for what we care about. So once you have a set, or we have multiple sets, you can do some operations with it. You can do some stuff with it. One fairly simple thing is to say, let's say we have two sets, and we ask ourselves how we can combine the two sets together. So we are talking here about the union. And basically the union of two sets is the set, it's also a set, which contains all the elements which are either part of A, of the first one, or part of B, of the second set. And if the set has elements in common, they will be part of the union. So if you are part of set A and part of the set B, well, you're also part of A or B. So the OR we say the OR is inclusive. So sometimes in common language, when you say you're in or out, it means that you can either be in or you can be out. You cannot be both. But in mathematics, if we say by default OR, it means that it's OR inclusive, that you can be both. So this is the union, right? So we can see, for example, that if we have only one set, we do the union of the set with itself, basically, then nothing changes. We have the same set. So next up, we have the intersection, which is basically the different operator, which AND. So in this time, we're going to say, what is the set made of elements which are part of A and also B? So instead of OR, this is now AND. And you can see that usually when you draw this is, we have made these potato diagrams. You can see the intersection is where these potatoes overlap. So sometimes when the potatoes are the set of these drawings, there's no intersection. And in that case, the intersection is empty set, which is also a set. It's just a set that has no elements. So speaking of no elements, we can ask ourselves how many elements are in the set. So we know already that if the set is empty, the number of elements is 0. The number of elements in the set is 0. And sometimes it's not a number, it's infinite. So for example, if you take the set of all the integers, that set has infinite number of elements. Because whenever set you have, if you choose a certain number of elements in that set or integers, then you can always have the largest one, and then you add 1 to that, and that should also be an integer. So it should also be part of the set. So we can basically make it grow as much as we want. So there's no end to this. The set has an infinite number of elements. But for all practical purposes, when we deal with sets in computer science, and cryptography is very much applied to computer science, especially cryptocurrencies, then we cannot deal with infinite sets. Nothing can be infinite with computers. We would not be able to represent anything with infinite sets. Well, it would be very hard, at least, to say the least. So our sets would always have a finite number of elements. And that number of elements is called the cardinality. It's just a fancy word for count of elements. So what we're saying is that the cardinality of our sets is going to be some number, some integer number greater than 0. Can be 0, but it cannot be negative. And but it can be very, very large. So the idea here is that even though our sets are not infinite, they're going to be with a very, very large cardinality. Okay, so what else can we do with a set? Well, there's one other thing we can do is it's called the product, the Cartesian product. So again, it's a fancy word, but it's actually quite simple. It's basically you have this time two sets. Let's say set A and set B. So I drew here two sets with on one hand we have sets with shapes, and the other set has letters. So just to say that these sets do not have to have the same type of elements. And the Cartesian product is the set where you pick one element of the first set and then a second element of the second set, and then you make a pair of these two guys. So if you look at how many possibilities you have, so how many elements of the product set you have, is going to be the number of elements of set A multiplied by the number of elements of set B. And that's just because if you take one element of for example, the first element of the set A, then you have, and let's say that the number of elements are m for the set A and n for the set B. You have n choices for the second element of B. And you can repeat that with any element of the set A. So since you have m of them, the number of possibilities you have is m times n. And in that little exercise, we want to keep the order. So if your sets, they can be the same, so you can also do the Cartesian product of a set by itself, which in this case you would have A equal B, or B equal A if you prefer, and then you do you pick one element of set A and one element of again set A. So it's as if you have two copies of the same set A, in which case you are allowed to take the same element twice. So for example, I have my first choice would be a square. I can take a square and a circle, but I also can take a square and a square, or a circle and a circle. And here it's very important to remember to keep the order. So if I choose square and circle, this is not the same choice as choosing a circle and then a square. So that's why when we write down the elements of the Cartesian product set, we make them as a pair. We write them in parentheses. We put a comma between, and this indicates that we care about the orders. So the parentheses here implies that we keeping track of the order. If we use braces, we are telling the elements of the set, so we don't care about the orders. So by the way, sets do not have orders. So if we have a set of square, rectangle, circle, it's the same as circle, rectangle, square. So order doesn't matter for a set, but it matters for pairs. And if you go on, if you take that and then you again do a Cartesian product with another set, with a set, you can have triplets, quadruples, and in general, if you have n elements or elements in that Cartesian product, so if we repeat that product several times, we can end up with what we call a tuple. So a tuple is a generalized term for pair, because if you have pair, it's implied to be 2. If you have a triple, it's 3, and so on. So if you, all these guys are called tuple. If you have n terms, it's called an n tuple. So when n equals 2, it's a pair. That's it for today. That's all we need to know about sets. And in the next video, we're going to talk about how we start associating these sets together. So we're going to talk about relations and about functions and operators.